In this tutorial, we're going to talk about calculus in physics. This is Physics is Easy with Mr. Jesse. Mainly, there are two types of calculus techniques that we will be using in physics or to solve physics problems. The first type is the differential calculus. Differential, let me just write it down. Differential calculus. And the second one is the integral calculus. Now, basically speaking, when we could integrate or differentiate a function. So when we say function, it's just very similar to an equation. All right, for example, if we have an equation, y is equal to 3x plus 4, we could actually write this as f of x is equal to 3x plus 4. So they mean the same thing, meaning to say that our y is actually dependent on x. So when your x changes, your y also changes. So that is what we mean by a function. So we could either integrate a function or we could differentiate a function. Now basically, when we say differential calculus or when we take the differential of a function, we are just going to get the slope of the function. So if we have a certain function, we could either graph it. So we could have a graph like this or a graph like that. So we just have to, if we are interested to know the slope of that particular graph or function, we just have to get its differential. On the other hand, if we are going to integrate a function, then we are actually trying to obtain the area under a graph. So that is the main difference between differential and integral calculus. So consider this velocity time graph with segments A, B, C, and D. So actually we could represent each segment by an equation. So in fact, segment A, I don't need to show this to you, but segment A could actually be represented by an equation. Let me just change the color. So we could represent segment A using the equation y is equal to 6x, or it could be written as f of x is equal to 6x. Similarly, segment B can actually be represented by an equation y is equal to 60, or f of x is equal to 60. So remember that when we say differentiate, it's just mean that we are actually getting the slope. And when we are going to integrate, we're getting the area. So if we are interested to solve for the acceleration of the object in segment A, then we could just integrate, or rather we could just differentiate the equation or the function f of x is equal to 6x, then we could actually obtain the acceleration. And if we are interested to know the displacement, then we could just integrate that function, integrate f of x equals 6x, then we will be able to obtain the displacement. The same is true for segment B. So if we are interested to know the acceleration in segment B, so for acceleration, we just have to derive or differentiate. And if we are interested to know the displacement, then we just have to integrate y is equal to 60. That is the application of calculus in this topic of physics. And we will revisit this graph later after we discuss the rules of differentiation. So the first rule in differentiation is the derivative of a constant is 0. So if we have a function and the function is just a whole number or any number, as a matter of fact, without any variable, then if we are going to differentiate that, the answer is going to be equal to 0. So here is an example of a function. Let's talk about a velocity function. So velocity as a function of time is equal to 4. So we read this part as velocity as a function of time, meaning to say that velocity changes as your time changes. But in this case, that is equal to 4. So it does not actually change. If we have, when time is equal to 0, it's still equal, the velocity is still equal to 4. When time is equal to 1, the velocity is still equal to 4. When time is equal to 2, the velocity is still equal to 4. This is what we mean by this particular expression right here. So it is constant. So in this case, the derivative of a constant is 0. So if we are going to get the derivative of that function, we could either write it this way, the derivative of the velocity, that is equal to 0. Or we could also write it this way, the derivative of velocity with respect to time. This is how we write it. Again, the derivative of velocity with respect to time would be equal to the derivative of whatever velocity is equal to. So originally, that's equal to 4. So we say the derivative of 4 with respect to time is equal to 0. Recall that when we say derivative, all right, when we say derivative, that actually just refers to the slope. Derivative refers to the slope. And remember that the slope of a velocity time graph, VT graph, is acceleration. So meaning to say, this quantity right here that we were able to solve is in fact acceleration. And that makes sense. If the velocity is constant, meaning it's constant in this case, it's actually equal to 4. So therefore, the acceleration should be equal to 0. So, and this proves that if we are going to get if we are given a velocity time graph or a velocity time function, or velocity as a function of time, if we are interested in obtaining the acceleration, we just have to get its derivative. The second rule for differentiation is called the power rule. So if we are going to follow this formula, it says here that if we have a function f of x and that is equal to x raised to the power of n, then the derivative of that particular function would follow the formula. So we will have an n there. It becomes the numerical coefficient of the variable x, and then the exponent, we will have n minus 1. Or we could also again write this in terms of d, or the derivative of x to the n, derivative of x to the n with respect to x is equal to n x raised to the power of n minus 1. So let's have an example. So taking f of x is equal to x raised to the power of 3. So if we take the derivative of that function, so that's going to be written this way. The derivative of the function f of x would just be equal to 3 x raised to the power of 3 minus 1, and that is just equal to 3x squared. Or we could say that the derivative of x cubed with respect to x is going to be equal to 3x squared. Let's state another example. So what if we have our velocity as a function of time, and that is equal to, say, 2x squared. So if we are going to get the derivative of our velocity function with respect to time, that is just equal to, so the numerical coefficient should just be written as it is, and then we are going to get the derivative of x squared. So according to the rule, or the power rule, we will have 2x 2 minus 1. So simplifying this, we will have the derivative of our velocity with respect to time is going to be equal to 2 raised to the power multiplied by 2 raised to the power of x, or simply equal to 4x. Now remember that the derivative of a function is just the slope of a function. So if our function is a velocity function, and if we take the derivative of that, we would actually get the slope. And remember that if we have a velocity versus time graph, obtaining the slope is actually would actually give us acceleration. So as a matter of fact, this quantity right here, or this expression right here, is actually equal to the acceleration of the object. So it's acceleration as a function of time. So what if our function actually looks like this? So let's have another example. So our function is f of x is equal to 3x to the fourth power plus x squared plus 2. So in obtaining the derivative of this particular function, we just have to apply the rule, the power rule, or the first rule to each terms in our function. So for example, the derivative of that function, or the derivative of f of x, would be equal to, so let's apply the rule to this. We will have 3 times 4x cubed plus, we will have 2x, and the derivative of a constant is equal to 0. So that's it. Then you simplify that. So the derivative of that function is in fact 12x cubed plus 2x. So once again, you just have to apply the rules of differentiation to each term in our function. So this mathematical skill is very important in physics, especially in the concept of position, velocity, and acceleration. Because if we are given the position function, say for example we have our position function, and that could be written as x of t, where x is the position and it is dependent with time. So meaning to say that when time changes, your position also changes. So if we are given the position function and we are interested to obtain the velocity function, we actually just need to get the derivative of the position function. So velocity function, that's going to be v of t. Similarly, from the velocity function, we could obtain the acceleration function by getting the derivative of the velocity function. So we could convert that into an acceleration function. Acceleration function, which is a of t. So let's solve a sample problem. For instance, we have a position function, or x of t, that which is equal to 4t to the fourth power plus 3t cubed plus 2t squared plus t plus 4, and we are asked to solve for the velocity equation, or the velocity function. So remember that if we are given the position function, we just need to get the derivative or the slope of that function to obtain the velocity. So we say v of t is actually equal, it's just equal to the derivative of the position function with respect to time. So in solving this, we just have to look at each term in our function and then differentiate it based on, or derive it based on, the power rule or the first rule. So we will have 4 multiplied by 4 times t raised to the power of 4 minus 1, plus we will have 3 multiplied by 3t raised to the power of 3 minus 1, plus 2 multiplied by 2t raised to the power of 2 minus 1, plus 1 multiplied by t raised to the power of 1 minus 1, plus 0. Simplifying this, we will have v of t is equal to 4 times 4t cubed plus 3 times 3t squared plus 2 times 2t and we will have plus 1 because anything that is actually raised to the power of 0 is equal to 1. So this part here becomes 1 times 1. And furthermore, we will have v of t is equal to 16t cubed plus 9t squared plus 4t plus 1. This is our velocity function. And if we are asked to solve for the acceleration function, we just have to derive the velocity function, so that we will have a of t is in fact equal to the derivative of the velocity function with respect to time. And this is going to be equal to 16 multiplied by 3t squared plus 9 multiplied by 2t plus 4 plus 0. So simplifying this, we are going to have acceleration as a function of time would be equal to 48t squared plus 18t plus 4. This is our acceleration function. And that concludes this lesson. Always remember, physics is easy with Mr. Jesse.